Welcome to Calculus Conqueror. Today we are going to take a look at limits. First of all, we are going to look at the function f of x equals x plus 1. And we are going to compare this function to g of x, which equals x squared minus 1 divided by x minus 1. Although algebraically these two functions look different, their graphs look identical. So, what is the difference? Well, we can factor g of x into x plus 1 times x minus 1 over x minus 1. And then we can cancel out those x minus 1 terms on both top and bottom. And that leaves us with g of x equals x plus 1, which is the same as f of x. Although both these graphs look the same, there is something different at x equals 1. When we plug in 1 for x, we get for f of x, or f of 1, it equals 2. For g of x at x equals 1, or g of 1, that turns out to equal 0 over 0. So at x equals 1, the graph of g of x does not equal 2, like f of 1 equals 2. And in fact, g of 1 does not exist at all. And that is because g of 1 is equal to 0 divided by 0. At x equals 1, the graph of g has a hole in it. Mathematically speaking, there is a removable discontinuity at g of 1. In order to show this graphically, we draw the graph of g with a hole in it at x equals 1. This hole is infinitely small, meaning that when we are infinitely close to x equals 1, our y value is infinitely close to 2. However, when we are at x equals 1, then we are in a hole in our graph since our y value does not exist. How do we express this mathematically? We express this through the idea of a limit. Although g of 1 does not exist, we can take the limit at x equals 1, and we write it as it is shown here. The limit as x approaches 1 of g of x is written as the limit as x approaches 1 of x squared minus 1 divided by x minus 1. Then we can factor like we did before and cancel out the like terms. And then we can plug in 1 for x, and that simply leaves us 1 plus 1 equals 2. So we can say that with our graph of g of x, the limit as x approaches 1 of x squared minus 1 divided by x minus 1 equals 2. Remember, though, that g of 1 does not exist. With algebraic notation, we cannot express what is happening with our function at x equals 1. However, with the limit notation of calculus, we can describe what is happening here. Namely, that as x approaches 1, g of x approaches 2. So back to our original graphs of f of x and g of x. With f of x on the left, function is equal to x plus 1, and at 1, f of 1 equals 2. With our graph of g of x, which equals x squared minus 1 divided by x minus 1, algebraically, g of 1 does not exist. But with calculus notation, the limit as x approaches 1 of g of x equals 2. I hope this has been a clear introduction to the idea of limits in calculus. Thank you very much.